Okay, welcome everyone. Go back our class. So the next class we will focus about how we define and display one qubit in a quantum state. So that is the next part for introduction to the quantum computing and programming course. So I hope after the first lesson about run the hello world, so we can try about the next part how you can define and displays one qubit quantum state. Okay, we will go step by step. The first, you will see this kind of you have a cat or the cat vector and matrix computation. This is going to illustrate how you can define the qubit 0 and qubit 1. So if you see in the screen, we need to first time you need to import the numpy or the array from the numpy, the library first, and the second. So this is a definition for the the aside about the qubit 0, yes, the qubit 0, and this is qubit 1. So if you remember from several previous lesson, we already introduced if you want to define the qubit 0 and qubit 1, we can transfer to the vector, transfer to the vector, and can support a kind of the quantum vector. So here is encoding. So encoding. So you can define array. 1 0. This kind of the array defined to 0. The cat 0 or the quantum bit. Qubit 0. And the second is qubit 1. So, and this guy display, that is called the computation. Computation, matrix computation is called the add, or plus. Then we plus to the values for qubit 0 and qubit 1. So this is a result. Okay, I will show you this code directly in the Colab, and we will see. Okay, and here we can have this code. You can copy from our code and and you can add a new file. And over here, you see we have you can click here, and this is the result, or is similar on the screen. You can see I run directly in the Colab, and it has the same result. And after you plus to the qubit 1 and 0, so we will have a result of the array is called 1, 0.5 and 0.5. And now we can go to the next part. We have try to multiply or try to add the matrix. Add the two matrix to the matrix together. If you see in the screen, we have the matrix M1 and we have matrix M2, and each one will be defined for different the qubit state. And now we can add to the value M1 over 2 and plus M2 over 2, and we can see how the result. Okay, I will try directly in the in the Colab, and we look how it look. Okay, and over here you can try. I copy code from my part to make sure we do not have any problem about the format. So if you see over here, you can click run. And you see the new result for the add matrix computation. So we have the result. This one is dimension is 2 2. Dimension is 2 2. And over here is one notice is very important to make sure. Okay, if you have a space, you have a space between the variable name and the operator and about the number. If you do not have, maybe it's they been make it confused. So when you create or you code in the quantum, try to remember, try to add some space between the variable and operator and the number. And okay, the next part we want. So over here we have two the matrix 1 and matrix 2, right? And we can multiply the matrix and with a number. Remember the cat 1 is a kind of the qubit 1. We already defined about the previous slide. And the M2, that's kind of the second matrix. And over here we have some important thing. We can multiply the matrix with the number, and we can multiply the two matrices together, and we run the different order for the matrix. So let us see after we run this kind of result, and we see array or the one that have some 3 points. First, you multiply the one the matrix with the one the qubit state. So like 1, so it doesn't change the state. The second, if you want to multiply the two matrices together, the order is very important. If you see on the screen, the second and third one, the array, the result will be changed. So this one, the result, and this one, the value change because the different order. So that is very important. In quantum, the order very important. Yeah, if we'll teach in the future, we'll see how it look later. And about the, we can have the other basics operator. We can assign the value for the one variable. Something like we can add a state of a vector. Yeah, and this guy of you know the positive the quantum qubit. Yeah. And the second, that is a kind of the quantum state. And the third one is not. This one is kind of in the integer or decimal, integer format. So integer space. So this one is not a kind of quantum. But based on the the quantum code, we can check which one is a quantum state, which one is not, by this kind of the code. So you can check directly, yeah. So we can copy and see how it looks in our code. So you can add this one more, yeah. And you can click here and see. So over here, if you run this code, so it will show to the format. One is a kind of the full mathematics formula, and the second is going to show the result in the text. So actually, this one is more visual, more visual for you to see the after we use multiply the two matrix or the one matrix with the the quantum together, and we see how it look. And here we can see the the full format, full format after you type in the text, you type in text, and this one a full format for the mathematics, and this one is calculate the value, or this in the decimal the value for vector. So that is first, this one is result. After output, you show the vector. So the next one, you can see we can check the valid for the quantum, that's kind of quantum state or not. This is kind of comment. So I can kind of show you directly in the code. So we can copy this one, and you can create a new thing. You can click there and see. You see the first one, and the second one is the quantum. The quantum state is true, and but the the third one is not, because over here, if you see, do not have a kind of imaginary the part. Only have a kind of reality part. Reality part in the number. Okay. The next part we will show about how you can measure state vector, and do not need to display about the text value. So this kind of code, this kind of code can help you to run a kind of measure. So it's most important over here. That is one that you can on the variable name plus measure the function. So after you run that code, you will show, state vector and show the dimension, dimension and the value for state vector. Yeah, kind of convert. And over here you can see after I change the value for state, the vector v with the new variable. So over here they can see show about the value in the quantum or in the complex vector, and show the dimension for the vector v. So have a two, the two over here is mean the qubit, two qubit and two dimension, two matrix. Okay, so I hope after this part you can understand how to define and display the 1 qubit quantum state, and try to assign a value for one of state vector, and try to show and try to verify if have the quantum or the vector is kind of quantum state or not. Thank you everyone.